We don't experience the world directly. Every feeling, every sensation, every memory is mediated by our neural hardware and software. Our brains, in fact, are not trying to reproduce reality perfectly, but instead they're using assumptions and neural shortcuts to get us, to help us to interact with the world and to navigate the world successfully, quickly, and efficiently. We call the cases where this simulation doesn't match reality and the discrepancy is largest, we call those illusions. For the last 10 years, Steve and I have organized the Best Illusion of the Year contest, where illusion creators, scientists, and artists from all over the world submit their newest, most spectacular illusions. And Michael Hawley has given us the challenge to show you 10 illusions in 10 minutes. Each one of them will show us something profound about the way our brains operate in everyday lives. And because we're doing a session about faces, the first illusion to show you involves faces, of course, and you're going to see two pictures, two faces, side by side, and a cross in the middle. What I would like you to do is to fix your eyes on the cross, and without moving your eyes, pay close attention to the faces. So here, keep your eyes on the cross, and you're going to see some pictures of celebrities. Okay? So keep your eyes in the middle, pay attention to the faces, and quickly enough, you're going to see that these faces become a bit not so pretty. They become distorted and grotesque. It's not a computer trick. It is all happening in your minds.
Stay away from my shoes if you're going to hurl.
To convince yourselves, look away from the cross, look at the faces directly. These are the same beautiful people you all know and love. Now back to the cross, and they again become not so fun to look at anymore. It is an illusion. What does it tell us? It tells us that for our brain, there is no ugly, there is no beautiful. Everything depends on what you compare it with. And what the illusion is doing is it's comparing every face with what happened before, immediately before, and exaggerating the differences.
You just keep telling yourself that. Okay, so this is called the dynamic Ebbinghaus illusion. We see two circles here in the middle, one's small and one's big. They're actually the same size, and they only look different because of the surround. But what if we took this circle out and just changed the surround? Nothing's happening here because they're separate, but if we put this one in the center, you can see that as the surround changes size and the center stays still, there's actually a little bit of a change in size there, but it's kind of weak. What if now we took the whole thing and just moved it while you paid attention to one of the surrounding objects? So pay attention to that yellow dot now, look at that, but pay attention to the center. Holy cow, that's a big change. It's happening on your visual cortex, but not in reality. Either that or you're completely nuts.
So you can see that whether it's beauty or it's size that we're talking about, everything is relative. We don't have absolutes for the brain. And what the brain is doing sometimes is taking very little information and making up a whole lot of it. So say we have 3 patches of gray, and this doesn't tell us much at all, but just by adding a little bit of context, by changing the angle between the patches, it kind of begins to look a little bit like maybe there is some 3-dimensional information there. What about if I add 3 Pac-Men? And then we change the angle between the patches as well. So you can see that now, with this very little information, 3 segments of gray, 3 Pac-Man, we see a rotating pyramid, a very complex perception based on very simple elements. Our brain is really making up a whole lot.
Here we have 2 stars. If you just pay attention to the one on the left and look in the center, you'll see that there's a green star and a red star. And then afterwards, when they turn off, you see an after image color filling the star of the outline that happens afterwards. Now what's interesting here, just stare in the center, is you'll see that the color that fills in is the opposite of whatever color the shape is that it happens to match, okay? That's impossible, okay, but it's happening anyway. What's also weird, and what will keep you up at night, is you'll realize the center here is always gray, Okay? So there is no color in the center here, and yet it fills in completely with whatever the color is supposed to be, you think, in your mind's eye.
A lot of illusions are about ambiguous information, and this information that can be interpreted in two different ways by providing one or other context, then it can look like completely different shapes in this particular example. Or say we're talking about black and white. We have two rows of chess pieces. They're exactly identical. The top one looks white, the bottom one looks dark. It's about the context. They're both exactly the same. Same with these 4 circles. In the left and in the right, exactly the same circle, only the context changes, the dark and the bright clouds. And you can also see it in motion. Looks very white, very dark. Again, it's exactly the same moon in both sides of the image.
Here we have the Leaning Tower of Pisa twice. You see on the right here, this one's leaning more to the right than the one on the left. In fact, that's not true. They're actually physically identical images. And what's happening here is when you see something that leans back and away from you, what should be happening is they converge in the distance. They actually get closer to each other in physical reality. But that's not happening here because these are 2 photographs of 2 parallel things that are actually parallel, even though they look like they're leaning back and farther away. So your brain interprets this as being that they must be diverging, and so your brain is helping you interpret what you're seeing. Now, what would happen if we took this and instead of doing it as a tower, we did it as, say, some roads going off into the distance? I'm going to show you 3, and what I want you to do while you're looking at this is point with your hand, put your hands out now so you can do this, point at the one on the screen that's different from the other 2, right? Like that one right there. But now, whoop, you're pointing at the wrong one. Now put your hands back. What did I just tell you? Okay, so keep looking at this. You'll see that this one actually matches this one here, okay? But what about this one? Because you can see it matches there. So, gosh, what's going on? Okay, so they're fully matching here. And when we line them up, they're going to match again, and that's completely wrong. We have no idea how this illusion works.
It just depends how you look at things. It's a matter of perspective. Like in this illusion, we're going to see that the point of view can matter a whole lot. We're going to see 4 ramps. They're made out of cardboard. And you can see now these little balls, they're rolling up the ramps. The ramps are cardboard. The balls are wood. There are no magnets. There is no CGI. What is going on? Let's look at it from a different angle. And you will see that, in fact, the balls were rolling downhill, not uphill as you had thought.
Okay, here we have a donut of blinking dots. Now, the dots are blinking in color here. So as you look in the center here, you'll see that each one of these is just cycling in color. Now, when this rotates, what will happen is the blinking will stop. Okay, so fixate here, and the blinking stops while it rotates, right? In fact, that's not what's happening. It's actually blinking on just like it was before. If you do it again, this time pay attention to one of the dots as it actually turns, as the donut turns, and you'll see that the cycling doesn't actually change at all. But what is happening is when you're fixating in the center, your attentional system has to either pay attention to the color changing or it has to pay attention to the motion changing. And one of the things that Susana and I discovered in our research in the brain about attention is that it suppresses everything else but what you're paying attention to. So while you're paying attention to the rotation, it suppresses the color changes and you can't see them. And this is actually what's happening in many types of magical misdirection and magic tricks as well.
We started off with a face illusion, and this is our 10th example. Another face illusion here with the portraits of Van Gogh and Rembrandt. They're very different portraits, both in color, in style, or are they? If we remove the luminance profiles, you can see that underneath the contours, the colors are exactly identical. Each color profile is a hybrid of both images, and they're both exactly the same. We can make them go back up. And you see how the brain takes the contours and matches the colors exactly to the right contours every time. You can swap the images and it still works perfectly. And it doesn't only work with faces. take these two landscapes. We have a forest and we have a Manhattan skyline. Again, the color profile underneath is exactly the same in both cases, but if we move the images back up, they match perfectly, and you can even swap them and still work just as well. The brain knows exactly what to do with color. Now, we have run out of time. We have shown you 10 illusions, but time is really an illusion. I think my Holly
Yeah, come on, Mike.
understand.
It's an illusion.
And so we have one bonus illusion to show you that I think a lot of you would have seen already, and you may be wondering about. This is the infamous dress that almost broke the internet a couple of months ago. And before we proceed, I need to ask, how many of you see this as white and gold? How many of you see it as blue and black? How many of you see it as something else?
Liars.
So we have a big new divide for humanity. We have cat and dog people, dress people. All right. Neither of you are wrong, and neither of you are completely right either.
So what's happening here is a lot of different things. We don't exactly know why half of the people see it blue-black and half of the people see it white and gold. But what we do know is this, is that lighting matters. For example, if we now take the dress and we show this part of the dress compared to this part of the dress, these two parts of the dress right here in the shade here and in the sun are actually physically identical coming onto your retina. They're physically identical. But this one looks like it's part of a yellow and white dress because it appears to be in the shade, whereas this one looks like it's part of a blue and black dress because it appears like it's in the sunlight. Now, if we actually look and see what happens, we find that sunlight is actually very special. Our color vision developed and evolved in history in the sunlight. That's how we saw color. So we always had to account for the blue light from the scattered blue sky and or the yellow light from sunlight. So our brains are evolved to deal with those specific colors in a very special way. So if we now take the same exact dress and put it in a sunlight context versus a shading context, we see two different colors as well. Now, if we take the actual dress, which is, by the way, actually blue and black, under white light, it's unambiguously so. But if we put it under blue light from the sky as well as sunlight from the sky, what happens here is that half of the people see it blue and black and half of the people see it white and gold, depending on whether you're sun people or blue sky people, dog people or cat people. I don't have any idea, but that's what's happening. Thank you very much.
So, what to take home from this? Illusions can be very hard to overcome. The same object to the brain can be, the same gray object can be blindingly white or it can be completely dark. And even though we know intellectually what is happening, we still cannot force ourselves to see the illusion in any other way. Now, it doesn't mean that we should try to overcome our illusions anyway, because these illusions are helping us to be efficient and to navigate the world and to accelerate our everyday interactions. But these same neural processes that are producing all of these illusions are important because we can use them, knowing what they are, we can use them to trick ourselves, if you will, into being more productive, into living even happier lives. Is your glass full? Or is it half full or is it half empty? It is all too often a matter of context and perspective. Thank you.